All right, so in this video, we're going to continue working with SQLite, and we're going to build a database from files that I have already prepared as CSV files. And we're going to use it to create tables, import data from those CSV files, and then do some example queries on the new database. If you want to know sort of more information about the tables and the information that's in those tables, I created a video in my Excel playlist that walks through that particular data file and how these CSV files were created. As noted in that file, those operations can absolutely be done in Python. But I did, for this particular example, I prepared these tables using Excel. It's a short file, so it was just easier to do for me. We're also going to talk about the pickle function. We're going to write some sample functions. We've dabbled with them in a couple of previous sessions. We're going to say a little bit more about them in this one. We're going to talk a little bit about lists, and we're also going to talk about some if-else statements and some for while loops. Again, we used some of these in the past for a simulation, but we're going to focus a little bit more in on them as we go through. All right, so we're going to resume our SQLite discussion. And so we're going to import our data frame. Now, we've mentioned in the past, we have this con function that is the connection to our database. I am going to create a new database from the information that we're going to import into our database. So this test DB1 does not have to exist in order for us to create it. Simply by calling it, SQLite will create it if it's not already there. And then again, our cursor function, which we're going to use to execute our various SQL commands. Now, I have, as I noted, I've created some tables that we're going to import into this database. The original data that I'm using for this was survey data that my students have been previously analyzing as part of their homework. It's not a very complicated database, information, but we wanted to use it as an example of database creation. So the ages are listed in categories. So I created an age table that is going to list the different age classes and what they stand for. And then it will connect to the main table with the foreign key to tell it what category they belong to. There's also a genders table. We're going to create the genders table. Again, we have text strings that are being constantly repeated. This is a good way to not only reduce the amount of memory, but ensure there are no typographical errors anywhere in the database. It's just constantly reusing the same information instead of having to retype it every single time. The data we're using had state information about the states that the respondents were from. So we're going to create a table that has their state information. And there's a table of their opinions on a particular survey question. We're going to create a table that, again, maps their opinions to a value. And then the respondents table is actually the main table where all of these tables come together. There is some individual information about each of the respondents, like their salary and their age or something like that, that are also, or their salary and the number of children that are individual to each respondent and which don't point out to another table. But then there are also these foreign keys that connect to these other tables, states, opinions, etc. Now we want to go through what each of these commands is doing in order to create the table. So we're using a generated ID for each of these in order to create the primary key, which is going to be called the age key. And then there is an age category. And in the age table, there is also, I listed a column for the age range. So to translate young. Well, what does young mean? In this case, it translates as being 34 or younger. And notice that in these strings here, we're using 3 quotation marks in order to mark out the command that we're using. Again, going directly into our execute function. To create the genders table, again, we're generating the ID automatically, which is an integer. The primary key is going to be called the gender key. And then there's also the name of gender, which is a text string. The states table, again, automatically generated integer primary key. The state key is an integer. The state name is in text. We're going to create the automatically generated primary key for opinions, which is an integer, and the opinion itself, which is a text. And then the respondents table, they have an automatically generated integer primary key. They have a person key, which is an integer, an age key, which is an integer, a gender key, which is an integer, state key, which is an integer, a children key, which is a children value. Notice it's not a key, which is an integer, number of children in the household. Salary, also a number. And then if you have dollars and cents, you should use float. But if you just have dollars, you can use an integer. And then opinion key is also an integer. That's the foreign key for the opinion. And then con.commit is going to send all of these functions to the database and build the database with the structure. And that did not take very long to execute at all. Now, right now, there's no information in these tables. It is just the table was created. So now it is ready to receive information. And so now I am going to read in the CSV files that I've prepared that have all the data that I want to put into the database. Now, I certainly can, if I wanted to, if I didn't have 200 entries, I could absolutely type them in manually. But I'm not going to do that here because I want to input a lot of data all at once. And so I've created these CSV files that contain the data I want to put into my database. So again, we're going to create our connection to the database, and we're going to read in the CSV files using pandas, and then we're going to send it out to SQL, the ages table with a connection. If it exists already, which it does now, append it, and then not add an additional, not keep the index that's already there. And then repeat that same type of operation for each of the tables that I want to import. So my genders CSV file will import it as the genders table. The state CSV file will import it as the states file, opinions as the opinions file, and respondents as the respondents file. And again, these tables I all prepared previously so that I know what order the columns are in and what information is in which table so that I could prepare these 2 sets of functions. And so that all got imported. Now we've seen in the previous video, if the path name is very complex, you can put R before the path name. I put all of these files in the folder that they're in so that they're as simple as possible. You do need to make sure that you add the CSV extension to the end of the files, otherwise it won't recognize just the file name without the extension. And of course, be sure before running the code, make sure all the column names in the CSV file match the column names that you created in the tables above. So you need to know what the tables look like and make sure that the columns match up. And then, of course, make sure all of the columns are in a text format. You can't have, weird things going on with them. and ideally things like no spaces and such. Now that we've created our table, we want to make sure that everything works. So we're going to use the function that we looked at in the previous video, and we're going to pass through some SQL queries into our new database to make sure that it all works. So here we're just going to select the respondents table and see what that looks like. And yeah, so here's our person key, here's our age key, our gender key, our state key, the number of children, the salary, those are all individual values for each respondent. They don't link out to a table, they're just here. And then the opinion key, again, links out to that other table. Here, I'm selecting all columns from respondents, doing a natural join with ages, and then a further natural join with the states. So again, you don't need to do these separately. You can do join, join, and it will join 3 tables together. And so now here we're matching out the age key to the age categories and the state key to the state names. So now we've created our database, and so now we can, as we saw in the previous video, we can now do our operations on them. We have it in a Panda data frame. We can do operations on pandas, or we could continue to do operations on SQL, but we have now created our SQLite database. And so now we have all the options available to us that we had from the previous video for the existing school database. All right, so now let's continue. Now we've talked a little bit about saving our files. We can also save our data frames or other kinds of operations once we have created them by using a function called pickle. So if you've been doing a lot of cleaning operations of your database and you don't necessarily want, or your data frame, and you don't necessarily want to start from scratch again the next time or rerun all of the code, maybe it took a lot of time to process and you don't want to reprocess it again, you can use the pickle function in order to read out, take your data frame, read it out to a pickle file, and then when you come back, you can resume where you left off by reading in the pickle file. And that's all the pickle function does. So to pickle, this will, if you go to your folder now on your computer, this will have a file name called dummy.pickle. And it's saving the data frame that I had just been working with as this pickle file. And then I read it back in, read pickle, same file name, and it reads back in the data frame that I was just saving. And then when you're done with the pickle file, you can remove it manually, or you can use this OS operation to remove the pickle file from within Python. So now if you were to go back to your file list, you would see that dummy.pickle is not there anymore. All right, so let's continue. We're going to talk about creating functions. So we've used creating functions a couple of times. In order to shorten a process, we have to repeat repeatedly. So rather than retyping everything, we simply create a function for it. Now, typically when you're creating a function, we've been doing it sort of very short shrift. But typically when you're creating a function, especially one that you want to reuse or share with other people, you typically want to include at the top of your function a statement about what the function is for. And so you do it in these triple quote things. And again, you specify what is the purpose of the function, and what any arguments are that might go into the function, and then any information that is returned at the end of the function. So the idea here is so that if someone else is looking at your function later on, they understand what is the point, what kind of information has to go into the function, and then what kind of information comes out of the function. So it's just useful in terms of, again, commenting out even to ourselves if we don't look at this for a very long time, or to someone else that's using the function, exactly what the function does and how it works. And then again, you can add additional comments into the function in order to further clarify specific things. And then in the past, we have only been using the actual code for the function, but it's always a good idea in general to explain what the point of the function is. Again, especially if you're going to share it or it's going to be part of a larger program. Now here, we're going to create a function that calculates the median. So the first thing that we're going to do in this case is we're going to take a list of values. We're going to find out how long it is. We're going to divide it by 2, and then we're going to convert it to an integer. If the length is divisible by 2, then one thing will happen. If the length is not divisible by 2, so divisible by 2 here, that's what this notation means. If that's 0, this is the remainder. So if the remainder of division by 2 is 0, so it is in fact divisible by 2, then the median is going to be the values at the midpoint minus 1 plus the values at the midpoint divided by 2. So you have an even number of values, you average the 2 values in the middle. Otherwise, you're going to this integer is not going to give you a fraction. It's going to convert it to a whole number. And what this is saying is it's going to round up. So this will be the sort of the midpoint and then just above the midpoint. So if there's an even number of values, you need actually the one below it and that one to be averaged. And if this is odd, if this divides by 2 and gives you a remainder of 1, so it's an odd number of values, this else condition is just going to report the value at the midpoint. And then whatever that was assigned, it will return the median value at the end. So we're going to run this to load the function into our memory. And then here's our list. 1, 2, 3, 4, 5, 6, 7 values. The median should be the middle value, which I believe should be the 10. Now, one thing to note here, this list is already pre-ordered. So if you give it an unordered list, this isn't going to work. You would have to sort the list first. And then here, our list, again, this has an even number of values, 1, 2, 3, 4, 5, 6, 7, 8. And so it's going to take these 2 middle values and it's going to average them to give you the median, which is 16. So halfway between these two. Now here's another example of a function. So the purpose of this function is to count the number of letters. So we're going to have some content string, and we're going to count the number of times that that particular letter appears in that content string. So again, content is a string, the string that we're going to search through, and then the letter is also a string, a 1-letter string, which is the letter to search for. And it's going to return an integer, which is the number of times that character occurred. And then we're going to add a section detailing what errors might be raised. So for instance, if letter is not a 1-character string, then it's not going to work. So if it's not an instance of the letter, or if the length of the letter is not equal to 1, we're going to raise a value error. Letter must be a 1-character string. And then that's just the error. And then the return is going to be the character we're going to look for a character in the content. And if it's that character, we're going to add it to the letter. And then we're going to give the length of that list. So if it's not that character, it won't be added to the list. If it is, then it will be added to the list. And then once we find all of the instances of that letter, then we'll calculate the length of that string. So for example, if I use this function on Happy Pi Day and I look for the letter A, then, oh, I don't think I ran this. I didn't load my function. There we go. So there are two A's in Happy Pi Day. There's one here and there's one there. Yeah, the function's not going to work until you save it in memory. But on the other hand, if I run the same content string, but I'm looking for pi, I'm going to get an error, and I should be getting an error because pi is not a one-character string. So the value error that it got reported is that letter must be a single character string. Now, if you're creating some sort of interactive program that you want to be able to take values from users, then we can use this input operator. And we can use this to experiment with our if, else, and elif statements. So in this case, I'm going to take two integers from input. This is essentially going to offer an input string. It's going to give me a place to put in a number, and then the user is going to put in a number, and then it's going to convert that input, which normally comes in as a string. It's going to convert it to an integer, if possible, and then it's going to run through. If my second number is greater than the first, then it's going to print this out, B is greater than A. If they're both equal, it's going to print out A and B are equal. And if the alternative is that A is greater than B, then it's going to print out A is greater than B, because there's only three things that can happen. So let's run this. So first integer, we'll say 5, second integer 9, and it says B is greater than A. Okay. If I run it again and I say 22 for my first one and 3 for my second one, it says A is greater than B. And if I run it as 7 and 7, it says A and B are equal. And if I run it and I put in G, I get an error because you can't convert G to an integer. So if you don't put in a number, you will get an error. All right, so then A is equal to our input. So again, we're going to request some inputs. Now here, if A is greater than B, we're going to print A is greater than B, but we don't have an alternative. So what's going to happen if A is not greater than B? So 5 and 1, A is greater than B. Great. But then what if we do 4 and 8? Nothing. A is not greater than B, and so there's no else condition, and so nothing happens. This if statement is not true, and therefore nothing goes on. I could request a third integer, 11. And so we're going to see down here, for instance, we're going to be looking at multiple conditions. So here is another way of doing the if-else statements if you don't have a lot of complications. So I find the syntax on this a little weird because it's different than the sort of default syntax. So here you're going to do the consequences of your if statement first. Print A if A is greater than B, and then else print B. So it's kind of like the if else is a sandwich in the middle, and the outcomes are on the other side. On the other hand, in the past, what we have said is essentially, if we go back to these, here's our condition first and then the consequences. So they take some getting used to, but this is a sort of one line if else statement, which can be useful. So our first integer, 11, our second integer, 15. Which one's bigger, essentially? B. Now, if we're running multiple conditions, sometimes you will need to enclose these things in parentheses um, in order to make sure to enforce the order of operations or to clarify your code. I usually just do that by default because I'm coming from math. But in principle, you don't necessarily have to do it, but Python may not require it and may still interpret your results correctly. But I find that putting things in parentheses sometimes just makes it easier to make sure that the if statements and the and op or the or operations are being done in the appropriate order. Now, we can also work with lists. So sometimes the output from our functions are going to produce lists. And so we can use lists also for our for loops and combine those with other kinds of operations. So here I've created a list of fruits, apple, banana, cherry. And for X in fruits, or you could say for fruit in fruit if you wanted, print whatever X is in this case. If X is banana, break. So here it does apple, banana, and then it stops. And again, you could redo this. You'll see this a lot in Python code, a lot for fruit in fruit, fruit. And if fruit is banana, and this will work exactly the same way instead of using X. Here we have, again, our list of fruits. For X in fruits, print X. This will just print everything in the list. It won't, as in the previous example, stop at a particular location. Here, if X is equal to banana, continue, and then print X. So again, our same list of things. So here, what it's saying is that if X is a banana, if our fruit is a banana, essentially skip over it and then continue, go back to the loop and start again. So it's going to print everything except banana. And you can also do for X in a range of values. You don't have to specify every value in the range. Or you can specify it increment by start with a particular value, end at a particular value, and then increment by a particular number of values. So for X in range 1 through 6, it starts at 0, 1, 2, 3, 4, 5, and then when it gets to 6, it stops. So Python starts counting at 0, so this means that it gets 6 outputs. The second half of this, it starts at 2 and it increments by 3 until it gets to 29, and then the next value is outside the range. It's above 30, and so it stops. Now, we have two kinds of loops in Python and most programming language, for loops and while loops. So generally you use for loops to run under a fixed number of steps. So do this 6 times, and you use while loops that run under a condition where the number of steps needed may not be known or may differ from run to run. So in this example, we're going to set our incrementer to 1 to start with. And then while I is less than 1, we're going to print the value of I, and then we're going to increment the I value by 1. And then when that's no longer true, then it's going to stop. And in this case, the else condition on the while just prints when the while loop is finished. I is no longer less than 6. So as we noted before with the fruit in fruits, we can do something similar with movie in movies. So you can try to find the first occurrence of a movie with the name money in it. And then if no value is found, no movie has that name in it, then you would print an error, an exception value. Now, I'm not going to run this because this is just an example of replacing that X with the singular for the plural list name that you have. So movie in movies, similar to our fruit in fruit. I don't actually have a movie index that I can refer to for this example. It's just a coding example for using these singulars with the plural list names. Again, the idea is to make the code easier to read and less sort of mathy.